Hello and welcome everyone. Today we are going to show you some techniques to analyze and process some data about real estate. Before we've done that, we have done some pre-processing already because we had like nearly 200,000 entries, and there were many things that we didn't need that were uninteresting for what we want to do, and we want to predict the sale price. And yes, so after the pre-processing, which we've done already, we carry on with the model here for the prediction. So in RapidMiner, you have a few tools, and you can get this one to start. It's to read the data. So you just go here and select your data, which is the pre-processed data. And then you select the attributes, and we just said that we don't want the house number to be in there. So we had a few more things that we don't want in there, but that is one of them. And yeah, so we don't want that in there. That's why we kick it out. So we say we want to invert the selection. So that's why we have everything else but the house number. Okay, so after that we want to filter the outliers. Like there are a few values, like they shouldn't be in the data because they're just too much over the top, and we have done some pre-processing and marked the outliers, and now we just say that everywhere where price out equals false, we don't want them in our data. So we filter them, and then we say we want to do some binning. So that just means that we have different classes, and we say we want 2 bins, but actually we will get 4 because we have a minimum and a maximum value. So we have from 0 to that, and then we have 2 classes in between, and then everything that is more than that. So it's 4 classes. Okay, and then we set a role. So we want to predict the price. That's why we set the price as a label. And also we need to set the ID as a role ID. Yeah, because it's just an ID, so we can't take this as a parameter where we can predict anything on. Then we split the data because we want to use 70% of the data for training and 30% for testing. So the 70% goes in here in the decision tree, and the rest goes in here, so we can apply the model and measure the performance. Okay, so in here we have a few things. You can see the values which we put in there, and if we run it now, you have to wait a second. Okay, so this is our graph. It's really huge. So it's all the decision it makes depending on the area, like what is your zip code and the sales date, when did you buy that, and yeah. So here you can see the performance, and you see it's 45%. So you think it's not very good because usually you try to get like something at around 75% or something, but like in our data, we don't have anything about the size or how old the building was. So actually, it's still quite a good prediction. But to compare it, we said we will use a different model. So we use the naive Bayes as well. So we can just enable the decision tree and run the whole process again. And yeah, then you see we do get a little bit of a better accuracy. And these are the values predicted correctly, always in here. And yeah, okay, so that was how we did it in RapidMiner, and then later on you will hear how to do it in WEKA.
Thank you very much, Kerstin. I will show you how to do the same thing with WEKA. For this, you first open the Explorer like we did before. We go on Open File, search the right directory for the file. choose the data which we already provided or pre-processed by R before. Then we have the imported data, and we see the price is the only numerical value. And we go on filters. We choose an unsupervised filter, which is decretance we use. For the configuration of this filter, it's quite simple. You choose the amount of bins you want to have at the end. You choose use equal frequency because we want to have in every bin the same amount of data. We press OK, and then we have to apply the model, the binning. Then you see now we got intervals between lowest value and a little bit over 80,000. Next interval goes to 140, the next to 240, and the rest is the rest. And we see every category has the same amount of data. Now we want to classify for this data. For this we choose the bias. We use a knife bias. We do the percentage split over 70% again, and we want to predict the price now, which is now nominal. So we press on start, and you see the system is generating a lot and is predicting the data. Here we see that we have a accuracy of 54%, which is not that good, but it's quite better than Kerstin showed you. And we see here the confusion matrix, which shows that every category is filled and the best categories or the best values are chosen in the correct. The most values are in the correct line, but there are still a lot of mistakes in. So for the second, we try to choose the decision tree. Decision tree is J48, and we press start for this. This decision tree takes a little bit longer time. I paused the movie for you, so it takes nearly 20 seconds now, and you see the accuracy of the decision tree is a little bit better than the knife bias, and we have also a bit higher values of the true expectations. Thank you for watching our videos. Was a lot of fun, and thank you.
Hello guys, today I want to show you how we use RapidMiner to define if a sale in our sale document about real estate was valid or not. So at first we load our real estate export valid file, separated by comma, everything fine, finish. But now we need to select the attributes which actually will help us to define if it's a valid sale or not. And we also have a value, an attribute which tell us if a sale was valid or not. So it will have either the value true or false. After that we need to set a role, the valid as a label, and also the ID as an ID. After that we're gonna split the data into 70% training and 30% testing. The first thing we're gonna try out is the decision tree, but as you can see in the results, it's pretty only one thing, and what it does basically is it predicts every sale as invalid sale. So the sale didn't come to a result, and that's incorrect, but it gets an overall accuracy of 81.53%, which is basically useless because it's only telling us that every sale is invalid. Now we'll change the decision tree to information gain, and we'll run it again.
Now you can see we get a way more complicated decision tree with a lot more nodes, and the performance changes also to 81.46%. And you can see some change. Earlier we had no prediction on true at all, but now we have some at least. But as you can see here, the percentage is still pretty bad. So what we are going to do now is we will change our model to a naive bias and disable that one. And if you run it now again, you can see that we get a worse accuracy of 70.8%, but like in the values you can see it's way more distributed, and we also get more predictions on true. So we get an 85% and a 49% here, which is still not good, but it's more information gain than before. Our best solution we got with WEKA, and that's where Andreas will tell you more about.
Hello everybody, welcome to our short tutorial how to do classification with WEKA. We have some real estate data from the US, and we are using this for classification if a sales is valid or not. For this we start WEKA and go to the Explorer. We open the file which we already pre-processed. We go to this file and choose our data. WEKA automatically loads the data, and you can see here that there are different data types in. We have two values of valid or non-valid. This is the big with false, so it's not valid, and here the true is valid. You see here the other diagrams, and a lot of different data is there. And now we try to make a classification of it. For this we want to do the bias, the naive bias. For the training set we choose 70% and do it on the valid. So we press start, and WEKA automatically builds a model and gives us and does the testing over the testing data. So we get automatically the summary. The summary says that we have an accuracy of 81%, which is quite good, and only 10,000 data are not correctly identified. And if we have a look at the confusion matrix, we see that it's on both sides the same kind of values, and we have a lot of values which are true and false and false. So the prediction was really good.